Well, welcome back to the lab. Yet again, we have another sick piece of equipment on the bench. In this case, it's one of my personal pieces of equipment. This is a Liebert UPS Station GTX-1. It's an older unit at this point. This is a online power filtering and conditioning UPS. I'll get into that a little bit more later with the two different types of UPSs. This is a high quality one. These are not inexpensive if you buy them new. I have one new one for my main computer. I need to get one for my editing computer, but they're not cheap because they do double conversion and power conditioning. After I get this one repaired, I'll pull the scope out and I'll talk more about that, show some waveforms. This particular unit, it was used when I got it. It still functions just fine. It squeals at me. The batteries are dead in it, so it's a little pissed off, and the fan's a little growly. So the only thing really I have to do to this thing is tear it apart, clean it, put a new fan in it, and swap out some batteries. This uses two small lead acid batteries, same thing that's in a car, to supply power. The smaller unit, this is their small footprint. They also have a footprint that goes in a 19-inch rack space. I like these little units for what I'm using them for on the bench. And they have a really neat feature because they're double conversion that I'll talk about when I turn it around to the back and give it a cleaning. Unit itself, this one is only 500 watts, so can't power a lot of stuff, but I am using it to power some of the more sensitive gear, some of the older signal sources, mainly the Type 184, 191, and 106, the big square Tektronix signal sources that I use for scope calibrations. More the 106 and the 184 versus the 191. So what I'll do is I'll plug it in here real quick, let it go through its startup processes. You won't be able to hear the fan that's growly, but I can hear it in the lab when there's nothing else on. You will hear the obnoxious beeping though, to signify that the batteries are dead. And I'll show you what that looks like on the front display of these things. So let me go ahead and plug it in, and we'll turn it on. Oh, when you plug one of these in, they cannot be on a isolation supply because these units actually detect whether they have a ground or not, and they get pissed off when they don't have a ground. So it's going through startup, and this is, oops, sorry, bumped the camera. This is the way the unit starts up. Essentially, the way the lights are reading is the load on the unit is very low. This doesn't indicate battery unless it's actually on battery. If it's not on battery, it indicates load of 0 to 100%. We're on AC input and we're on bypass. So what bypass means is it's not filtering any power, it's just passing power cable from the wall through the unit and out the back. So what I'll do is I'll turn it on. There it goes. So it went to UPS on. Now it's testing the battery. So now this is indicating battery load. And it's still testing the battery, still testing the battery, still testing the battery. Still testing the battery. Okay, now it's settled down. This is normal operating procedure for one of these UPSs. Load, AC input, and UPS. There's no load on this, so the inverter didn't actually see anything. The more load you put on the UPS, the more current the batteries have to deliver to the inverter to step up the 24 volts DC to 120 volts AC. When I had some stuff plugged into this, it started screaming at me, and this red light came on that said the batteries were weak. So what I'll do now is I'll get the unit torn down, I'll get the covers off, and we'll take a look at the batteries and see what they're doing. I'll use the bench power supply, charge up one of the batteries, and just see if we can load test it. I'm sure they're both old. I'm not even sure they're the same model at this point. I have to open up and see what's in it. But I'll get that opened, and then I'll be right back. Well, this is a disaster. I got this unit used, and it is filthy inside. I should have opened this up and cleaned it out before I put it up on the bench. Didn't look too bad from the outside, so I didn't think it was going to be this bad on the inside, but this is real bad. So this is the fan I need to replace. Batteries are on the other side. I haven't taken them out yet. So essentially what these units are is they take wall power 110, they rectify it, turn it into DC, charge the batteries, draw off the batteries in the charging circuit to run a very large switching power supply, which is why some of these coils are absolutely massive. Kick that back out as very clean sine wave AC. Nothing's in bad shape. I don't see anything initially that looks like it's popped or blown up or anything like that. This one's actually a pretty small unit. I tore down a 2000 VA unit, and the IGBTs, the rectifiers and things like that were 3 times that size, so they were actually pretty huge. What I'll do now is I'll get the batteries pulled out, and like I said, these things do a lot of current. That's you can't see it. Move that. That's on the hot side of the battery terminal. That's a 40 amp fuse. So under full load, this thing is expected to draw close to 40 amps out of the batteries. So they'll pull batteries down pretty quick if you ask them to do a lot. Fortunately, I'm only asking it to do a couple of 100 watts, so not too big a deal. Lots of power filtering in here. Clean sine wave on the out. Clean, making sure none of the switching noise gets out onto the line. So units are really rugged. Unless something really happens to them, typically they just need batteries replaced. Coils are huge. These are the tuning filtering coils on the output to get the sine wave at the right frequency. So I will work on getting this cleaned up and see what kind of batteries we need for it, and then I'll get some parts ordered. Okay, here's the battery module out. As you can see, it's actually got a spot for 3, but there's only 2 spots populated at the moment. Turning this thing over to get the batteries out just littered my bench with stuff, so I got out the vacuum and cleaned up a little bit. So these haven't been opened yet, so I don't think this battery pack's been worked on at all. Let's see if I can... Oh, nope, they're cut. They've been opened. Okay, and there are some batteries. So these are the types of batteries that these UPSs run on. Actually, these are a pretty common size for most computer and server room UPSs. This one looks like it's leaked a little bit right here along the seam. Looks like there might be some electrolyte coming out of there. Pull these out. And these are just wired up in series. Ugh. So here are the batteries. Here's the unit. So a couple of ways these batteries fail is, let me unplug these real quick. Ow. Let's see if this did. No, that one's okay. So 2 ways that I've seen these commonly fail is they'll expand where the case will have waves going down the side. Going down here, you can just feel it by running your hand along it. This one's okay. The other way they die is they actually, if you shake them, just shake them like this, they rattle. So I don't know what exactly comes off internally in these. That one's maybe a little bulging. So I don't know what exactly comes off internally in these, but they're not supposed to rattle and they're not supposed to be expanded. So if you see any of those, the battery's just done. These are gel pack batteries, actually, these particular ones. So they're not like a car battery where you can check the water, give them maintenance, anything like that. They're sealed, non-spillable. So I will be recycling these with my local battery recycler. Fortunately, the same store I get the new batteries from, he just takes the old ones and recycles them appropriately. So I will... I'll hook up a meter and we'll see what's going on in these batteries, see if they got any life in them. My guess is they're pretty toast. So let me do that and I'll be right back. Okay, so I have the battery hooked up to one of my power supplies in the lab. I have it set to 14.1 volts to charge a 12-volt battery. That's only because it's lead acid chemistry. Battery charging is very specific on how it wants to be taken care of, especially with the larger new lithium packs and things like that. So I can overvolt it just a little bit because it's lead acid but charging a battery off a power supply with no protection, you have to be real careful because the batteries could explode. If I turn this back to amps, we're drawing about half an amp, so the battery's pretty dead. So what I'm going to do is I'll just leave this sit for a couple hours, let the power supply charge the battery. We'll see what comes next, if the batteries are good or bad. My guess is they're bad. I'm going to replace them, so we'll go from there. Well, I got the case torn down. The batteries have been charging for a while. What was happening on the voltmeter was they were drawing about a half an amp, so they never really came up to the full 14 volts that I was asking them to charge to. And then when I took the power supply away, they dropped back down to 12.8-ish. So they got a dead cell in them. I'll have to replace those two batteries. No surprise there. Hit the unit with an air compressor. Looks better already. So all the dust bunnies are gone. Everything looks good. Turn my attention to this fan. The way these fans are put together is if you pull the label off, there's a bearing right here in the top. And they're held in by that tiny C-clip. There we go. You pull this tiny C-clip out, then the shaft pushes out through the front, lets you get into the motor, fans, and the grill. This is what's just in the bottom side of the motor, just a couple coils. This internally, actually looks pretty good. This outer cage needs a cleaning bad. So these fan blades are just caked with dust and dirt and things like that. So what I'm actually going to try to do is I am going to try to clean these and just get them cleaned up. Just going to spray some alcohol on here so to soften them up a little bit. Won't hurt the electronics at all. Just get that to soften up. But to give you an idea as to what's actually on here, I'll just take all I did was wipe down one fan blade, and that much came off. So let's see if I can zoom in on that, give you an idea just how dirty this thing got. There we go. Nope, yeah, there it goes. Okay. So I'll do that again. That's how crusty this fan is. So let me get everything cleaned up on this fan. I'll get all the blades wiped down. I'll get the frame wiped down real good. And we'll put it together and we'll see if it still makes a growly noise. So I will get that done and I'll be right back. Well, I got to go wash my hands now. I've got the fan cleaned up and everything like that. This is the carnage from all the cleaning and stuff like that, and my hands are pretty filthy. So I'm going to go wash my hands real quick, and then we'll reassemble that fan, put 12 volts to it, and see if it sounds crusty still. That was real bad. That fan was pretty gross. Okay, just doing the fan testing real quick. Well, it's turning. So I can hear a little bit of bearing noise out of the fan, but it's definitely much improved. So we'll put it all back together and see what happens. If it's still a little crusty, I will have to order a replacement fan. I'm going to shorten these leads. I need to order some plugs so I can get these shorter to keep the EMI down in the lab. I just need these to come down to here. We'll just take up 2 of those, so those will just come right over here. One of the reasons I like these Liebert units, I've got the fan put back in and the side put on. I need to wait for batteries to come in. But one of the reasons why I like these small square Liebert units, I have to check and see if they do it on the larger ones, but these small square ones is because of these switches right here. There's 2 tiny switches right here. And if you look down here to this chart, those 2 switches can actually set the inverter voltage on the output. So even though we have 120 coming in, I can dial 100, 110, 120, 127. So what that allows me to do is because I have some older gear like the 184, the 191, and the 106, I can actually dial those to 110 volts, which is what they were designed to run on. I can drive the older gear on the voltage it's designed for, so I don't overdrive it. This also gives them absolutely clean power coming out of here, which I'll show once I get batteries put back in it, due to the fact that these particular units won't start up when there's no batteries in the bottom. So they need battery voltage to actually turn on. So when the batteries come in, I'll get the case put back together, get that thrown in here, and then I'll do some measurements. I'll show some sine waves coming out the back of this, and I'll compare it to a less expensive UPS that's not line interactive and power conditioning. That's just, I don't know how widespread the term is, but they're called bunk and chunk UPSs. They just wait and then they kick on. The sine waves for them are actually pretty ugly, and some stuff doesn't mind, like computer power supplies, things like that don't mind. Some stuff gets real pissed off, like motors. So it's good to know what you're plugging into these. But these power conditioning UPSs, these things are great, wonderfully clean power. So what I'll do is I'll get everything put up. Next shot, you'll probably see these will be tied up. I'll have batteries in it, and we'll get out some test gear and take some measurements. Okay, today is tomorrow, and I have a couple of new batteries. I also have some, where'd they go? Some Levitron plugs we're going to use on here. Got 2 new batteries to put in the frame. They're the old ones back there. So I'm going to get these 110 leads shortened up. I'll get these batteries put back in the frame. Once the batteries are back in the frame, I'll get one of my other UPSs. We'll fire this thing up, make sure it works, and then I'll get the Rigol out, and I'll show you the difference between the power conditioning UPSs and the offline UPSs. So let me get all that stuff put together, and then I will be back. Okay, we'll let the scope boot back up again. Now the scope's on a different UPS. So the yellow trace is the Liebert, the purple trace is the APC. What I'm going to do is I'm going to turn off. Everything's good, and we have a trace. So the scope is actually set up AC coupled at 100 volts per division. So we're seeing the 120 volt RMS sine wave coming out of the wall. Do not do this. I'm pushing the scope beyond its category limits on its inputs. You need special equipment to scope mains voltages and isolated scopes. This is ground reference. Don't do this. So what I'm going to do is I'm going to turn off that power strip in the back, which will kick both UPSs over into battery mode. Watch what happens to the sine wave. I'll zoom into the scope. The scope is running. It's triggered. It's everything. So no trickery. All I'm going to do is turn off the power. You will hear some beeping when they go into alarm, when they lose electric. And there we go. Main difference between the 2 different types of UPSs. The online power conditioning UPS is still a nice sine wave. The APC, which is down here, nothing moved. All I did was turn the power off. That's supposed to be line power. Now, some loads don't care. Computers don't care. A couple of things like that. This is a computer UPS. I use it on my own computers. It's just the way the inversion is. There's a huge cost difference between the 2 UPSs. I don't expect the APC to put out clean filtered power like that. It's just not in the same category. So everything is performing exactly as it should and in spec. But if you have a freezer, refrigerator, something like that you're trying to back up, computer power supplies, the reciprocating compressors and the motors in those power supplies do not like being fed square wave power. You can actually burn up the compressor. I'll just turn the power back on, and you'll watch the purple wave go back to normal. Power's back on. UPS, the inverter in the UPS just turned off, and everything went back to normal. The Liebert's actually still running on battery until that orange light goes out, which it just did. So it even stayed on battery a little bit longer than the APC did. One of the reasons why I use the Lieberts for some of the more sensitive and irreplaceable gear in the lab, the 184 or the 106. They work very well. The APC works great too. So, but I don't ask it to back up my analog gear. I ask those to back up my computers. So, the differences between the two UPSs, tear all this stuff down and make the bench safe again, and also get that APC back underneath my bench because I need to edit a video for YouTube. So I got to get the editing computer powered back on. So if you guys have any questions, go ahead and ask them in the comments. And I will see you guys next time.